Hello, everyone. Welcome to our continuing webinar series on AMS CAM system. Today's webinar title is Fine-Tuning CAM System Performance, and we've been judging by the number of responses and number of registrants we've had. Looks like it's a very popular topic, and also we've had a lot of questions recently about this, so we decided to do this webinar. My name is Joe Anand. For those of you who don't know me, I'm the product manager here. I'll be joined today by Don LaCourse, who will be actually doing the show and tell. So before we get started on that, there are a few small housekeeping tips. Use your chat window for questions, and you can, that blue arrow you see on the graphic screen that shows you the chat window that you can use to enter your questions. I'll be in the background watching for your questions, and I can answer them either by text, or if need be, we can ask Don to stop and show you some aspects of the question to explain it a little bit better. We also reserve the last 10 minutes for questions and answers, but we would like to keep this as interactive as possible, so don't hesitate to type in your questions as the webinar is progressing. And then, as usual, the recording of this webinar will be made available in a couple of days. We'll clean it up and send an email out to all the registrants. Okay, and today's agenda is basically we're going to be talking about how you can fine-tune your CAM system performance, obviously. We're going to be starting out with talking about the different performance indicators that you should be aware of. We'll start out with the system performance, which is basically the machine or the PC that you're using. And then we'll go into the specifics of toolpath generation performance parameters and things of that sort. What are the things that you can do to actually increase and improve performance during toolpath generation? And then finally, we're also going to be talking about how to improve performance and fine-tune that for simulation during toolpath simulation. So these are the main areas that we're going to be talking about. So Don, go ahead.
Okay. Hello, everyone. I'm glad you could make it this morning. And this topic is on everyone's mind all the time, whether you're a new user or a well-experienced user, whether you're on a new computer or a old computer. So what we've done in this webinar, we've broken it up into three main categories, starting from left to right. You've got your hardware and your system performance. We're going to be talking about that, the base requirements, recommended requirements, and some recommended practices. And then also the two main areas in the CAM system that that uses resources on that computer, of course, will be toolpath generation, the time it takes to actually see a toolpath when you pick generate, and then also the simulation process. So after you're done editing your toolpath, you want to see the results. So we're talking about from the time you pick play on an operation to see the simulation to the time that it ends. Okay, let's talk about the computer hardware aspects of your system. On the top of this slide, we have just recently updated these requirements. So if you haven't looked at the base requirements recently, you want to take a look at this top section right here. These are just base. Base means you can get away with running it with these, but you probably don't want to run it with these for very long if you're doing like large models or complex models, or if this computer is the one that's making you money, you might want to think about upgrading some of these base requirements. So basically the CPU requires 64-bit. It doesn't matter whether it's Intel or AMD.
Actually, Don, we do run on 36-bit as well, but the issue really is when you add large models to your system, you would want to do 64-bit, go to 64-bit.
Okay. minimum RAM is 8 gigabytes. Again, the more RAM, the better, and I'll talk about that in the recommendations below. Disk space, obviously. We now run on Windows 8, 10, and 11. So if you're going to upgrade to Windows 11, you can go ahead and do so without any concerns.
Yeah, we just recently certified our products to run on Windows 11. We just went through a whole host of testing process, and we're happy to announce that we do run on Windows 11. We'll be sending out a press release pretty soon announcing it.
Good. And then for graphics, if you're going to use a base graphics card, just make sure it supports OpenGL, and that is the graphics language. And then down below that, some recommendations to jack up your computer so that you can get more work done faster. Obviously, the faster clock speed of your CPU. Basically, these bottom ones are how much you can afford to put into this computer that's going to end up generating the toolpaths that make you money. So just kind of think of it like that. If you can go to solid state drives, no moving parts in the drive, no disk spinning. So those are obviously faster to get data in and out of your drives. We didn't give a max RAM. I just wrote the more the better. This computer right here has got 32 gigs of RAM. It used to have 16, and I upgraded that only because all of the models that we work with here, 16 was just taking too long. So you might want to think about, again, this is just how much you can afford, and RAM is something that you can add. If you want, later, if you want to add more RAM, you can, if you're computer savvy, you can pop them in yourself, little RAM modules, or take it to your local computer store and they can match up. The RAM has to be matched to your clock speed, so you need to make sure what you buy matches your motherboard. And then also, you can add a dedicated graphics card. For example, this machine here that we're looking at has an NVIDIA Quadro graphics card. If you're going to get a new graphics card, recommend that you go to OpenGL 2. That is the latest graphics language on the graphics card. So those are the base performance indicators at the top, the recommended system requirements on the bottom. Now, some tips for better performance that relate to your computer itself. Now, you go to bed every night and you wake up every morning refreshed. You need to let your computer do the same. I know we tend not to do this, but obviously it's better for the computer if you shut it down at night, give it a rest, boot it up early in the morning, and you'll see noticeably better response times when you start working in the morning.
I got to break in here. I mean, it's not like the computer needs rest. I mean, that's not the reason we
That
do
was just
it.
an analogy.
Yeah. So the reason you do that is our system and any application you run is built on a whole host of other system libraries and a whole bunch of other components. And all these components, however good the system provider is, tend to leak memory. So what happens is as you keep running these systems, this is a fact of life. They eat up memory and they don't release the memory. So the more you run your system, your PC, the more memory that's going to get locked up. And then pretty soon your PC is going to start crawling because there's a lot of this RAM that really cannot be used by your system. So effectively you reduce the RAM. So that's why when you shut everything down and bring it back up, all this memory will be released, and then you can be going on your merry way again.
Mm-hmm. Okay. Now, also, just a couple of little tips under that. I know we all, when we're working all day long, we tend to have multiple sessions of our CAD system running in the background. And we have done support sessions with users who we discover have got 7, 8, 9 sessions of RhinoCam running, and they're working on one of them. So every one of those sessions takes system resources away from you, away from the session that you're working in. So try to get into the habit of only running one session at a time, and that'll be your optimum performance. And then obviously each of the CAD systems we run on have autosave options. Obviously, it's a good idea to activate those. Autosave every 5 minutes or so. You may think it's an interruption, but actually it may save you a lot of time if you had a computer crash or something went wrong. And then also, we're going to show you how to allocate resources to the CAD system so that it has a priority over other resources. Okay, so what we're going to do, we did something a little bit different this time. We're going to pop in and out of some demos for each of these performance indicators. We're not going to do one large demo at the end. So we're going to go and do a demo now based on the hardware performance indicators. I'm going to show you a couple of things here. Just one second. Okay, so I obviously have RhinoCam running with a part loaded, but what I want to show you here is how to check if you're new to computers, and we have a lot of hobbyists, a lot of retirees who use our product, they're not that computer savvy. So we're going to be talking about some real basic things that you can check. Many of you may obviously already know these, so just bear with us as we show these for the new users. So how to check your system information, how to know what your system is. So we're going to go down here to the Windows search bar, and we're going to type in system. And we're going to pick system here. So it's going to pop up a window, and it's going to show you what's on your computer, the manufacturer, the model, the processor that you have, the gigahertz, the speed of your processor. This is a good indicator of how fast your CPU is running. And also it's going to tell you how much RAM you have currently installed. This one has 32 gigabytes of RAM. And it tells you the operating system that's installed. This is a 64-bit system. So these are your base indicators of the computer that you're running right now. Now, if you want to check and see what kind of graphics adapter you have on the computer, you can go up here to Device Manager, select that, and it'll show you everything on this computer. And what you want to look at is the section for display adapters. That's your graphics card. Just open that up. And in this machine, it says it's got an NVIDIA Quadro K2200 graphics card. And then we may, if we're talking to you about performance, we may ask you to make sure that your graphics card drivers are up to date, because they can become out of date. And when they do that, you may end up having system problems, especially during anything that relates to using your display, toolpath generation, obviously toolpath simulation. But if you just select on your graphics card that you have listed, right click, and there's an option to update your driver. So go ahead and do that. Windows is supposed to do this or let you know, but we found times when they're not letting you know. So it's always good to maybe once a month go in there and update your graphics card drivers and make sure they're up to date. Okay, so let's go back, close that, and go back into the RhinoCam session. Now, the session count, how many sessions that you have. If you go down on your task bar here and you go to your RhinoCam or Visual CAD CAM or SolidWorks, whatever, and just highlight the icon on your taskbar, if you have more than one session running, those will line up on, it'll show up on little icons above your main icon on the taskbar. So if you see number of sessions of RhinoCam or Visual CAD CAM running here, it's a good idea. The ones that you do not running or want to work with, go ahead and close those down and only work in one session. Now, also, a lot of users, when you first run a Rhino, you'll come up in a multi-viewport display like this. It's recommended that you don't run in this configuration all the time. Run in one window at a time, and you can pop in and out. A lot of times we'll pop in to this in order to see an elevation view of a toolpath, say from the front view or whatever. But it's always good just to stay in one view and work, because resources are only being allocated for that one window. Okay, and one last thing that I wanted to show you was you can allocate system resources to an application. So if you know you're going to be running a simulation, and you know this simulation takes 15 minutes, and that's not uncommon if you got a really complex model, you can go down here and just right-click on your taskbar and pick Task Manager, and that'll display all of this applications and snippets of resources that are running on your computer at that moment. If you want to get more details, just go to the details section, and we're going to scroll down to RhinoCam. Right-click on that and set priority. You can give RhinoCam a low priority or a real-time priority, meaning that it's taking the system resources in real time away from other applications or subsystems. So we're going to set it to real time. Pick change priority, and then close your system window. Okay, that's all I've got. Joe, unless anybody's got any questions about systems, we're going to pop over to the next section.
One other comment I would make is keep your system up to date with Windows updates. That's very important, not only for performance reasons, because Microsoft does fix a lot of bugs in each of their updates. So keep that automatic updates turned on. That makes your life a lot easier in terms of performance, not just performance, but also for other reasons.
Okay, thanks. Thanks, Joe. Okay, so let's go back to the presentation. Now we're going to talk about the first indicator was geometry, toolpath generation, and simulation. So we're going to talk a little bit about geometry, because geometry plays a big role on how fast you can get your work done. We support 3 types of geometry, starting from the left to right. Just 2D curve models. If you're just machining prismatic parts, you don't have to have a 3D model. You can machine 2.5 axis toolpaths with only 2D curves. And that obviously is the fastest or a faster way to get your toolpaths generated. But again, this is only limited to 2.5 axis toolpaths. You can't do any 3 axis operations with only curves. So if we move over to the middle, this is your normal operating mode, where you're going to be working with 3D NURB surfaces. The NURB surface is just means that it's a complex surface definition. Most CAD systems, when you're working with surfaces, they are NURBS based surfaces. So this will be your normal mode of operation. It's a little bit slower than 2D curves, obviously. And then the third type of geometry we can run with is 3D mesh models. Now, the 3D mesh models, if you have to work with meshes, you can work with them. But if you don't have to, we recommend that you don't. If you can recommend, if you're getting geometry from a customer and they say, what do you want? What kind of file types do you want? Don't say you want a mesh model. Say you want a NURB surface model. If you're importing the models, those would be a step format, STEP or STP, star.stp as a file extension that handles solid models. And then also you can ask for IGES models, IGES or star.IGS will get you the solids, get you the surfaces as well. But only use star.stl or STL files or mesh files only if you have to, because that will slow down your system. Okay, just while we're on mesh models, I'm going to show you the difference between the performance of two very similar mesh models. You can't really tell the difference looking at them, but one mesh, we're talking about the Bulldog in the middle. This mesh has 700,000 triangles in the mesh. That's a very dense mesh. And the one on the right has 50,000 triangles. And if you're getting a mesh from a customer, they have the tools to reduce the mesh count, reduce the triangle count in the mesh. So I would ask them to send you a high dense mesh and then a low dense mesh. So you may end up using the low density mesh because it's not going to degrade the quality possibly, and it's going to be a lot faster, as much as 75% faster.
We also have mesh tools that you can use. Those are separately, you have to purchase them as a separate module. I would recommend getting a really high density mesh, then using reduction tools depending on your application to do the reduction yourself if you really have to work with meshes.
Okay, so let's take a look at a mesh model, and we're going to look at, we'll do our dense model first. So here's the mesh. If you want to see what the triangle count looks like, at least from a visual standpoint, you can go over to your display tab on the right and turn on mesh wires. And you can see it turns black only because the dense is really really dense, I mean. And if you zoom in, you'll see the mesh triangles. So this is, like I mentioned, 700,000 or 600,000 triangles in this mesh. So you have to machine this mesh. So let's go ahead and turn the mesh wires back off so we can at least see what we're doing here. So we got one tool path here, which is a spiral path that is cutting that mesh out. So let's go ahead and do a generation on that. And I had a stopwatch over on the right, but it looks like the webinar has frozen the stopwatch. So we'll just do it by ear or by visual. So it's computing the 3-axis finishing operation on a very dense mesh. I timed these before. I believe it was like 35 seconds. It was under a minute. Let's let that work. And again, you can see the toolpath being created. Okay, so that was about 35 seconds. 700,000 mesh triangles. That's just to generate one toolpath on this mesh. Now let's go into another file that is a reduction of the mesh. I apologize, I picked save. I meant to not to save it. And again, here's another thing right here. 700,000 mesh triangles in this part. It's going to attack your system no matter what you're doing. Saving it, loading it, creating operations, simulating, everything gets taxed. So here we have the same part, a less dense mesh. Let's take a look at the mesh wires. So there's not as many meshes. Now there is a quality trade-off here because you don't have as many mesh triangles. You don't have as much definition, but it depends on how you're going to machine that and what it looks like when you machine it. So you may not need the higher dense mesh. So let's go ahead and regenerate this. This is 50,000 mesh triangles. And when I tested it prior, it was about half the amount of time, about 15 is already done, 10 seconds. So if you can, if it's allowable that you can slightly reduce the quality of the mesh, but still get represented what you need to get represented by lowering the density of the mesh, that's definitely what you want to do because it will save you on resources every time you use it. Okay, so let's go back. Joe, you got anything to add? Any questions?
Yeah, the other option is you can, if you are not unsure about how you're going to machine something, you can always bring in a low density mesh and then experiment with the machining part of it with that low density mesh, because things will obviously go quicker. And then once you're satisfied about how you're going to approach the actual machining, what are the machining operations you're going to use, then finally you can load the high density mesh and repeat that, or even save that operations as a template and then load them in. Knowledge base, and then load them in and regenerate everything. So that might be an option to speed things up. So.
Okay, and actually, there are a lot of users that use mesh files that are prismatic, like mold bases and things like that. If you're working with a prismatic part, there's no need to have 50,000 triangles. Okay, if it's just straight edges, straight walls, you can reduce that mesh, 99%. So let's go back into the presentation. So that was the geometry performance part. Now we're going to look at the generation, toolpath generation. So what are the indicators for the length of time it takes to generate? Obviously, we talked about geometry, curves, surfaces, and mesh. That's going to affect your regenerating times. Your cutting parameters obviously going to affect that. And there's a few parameters we're going to look at it here in just a second, which are major contributions to the time it takes to generate a toolpath, as well as the machining preferences, and obviously your CAD system tolerance. Typically, your CAD system tolerance is set at 1,000th. At times, you may increase or decrease that. Probably wouldn't want to decrease it a lot less than that. But regardless of what it is, it contributes to the amount of information that's cooked into that surface. So it will add some time. It won't be a lot noticeable, but it does add some time. And then at the bottom here, we got some general toolpath generation tips. This is my little tip here I put in here. You can start with the default parameters. Joe mentioned with starting with a low density mesh. You can start with the default. Every toolpath you load, if you haven't ran it before, it'll start up with default parameters. And those parameters, pretty much in all cases, will generate a toolpath. So you can do a quick generation with the default parameters with your geometry just to verify that, yeah, I'm getting a toolpath. It was, regenerated pretty good. Let's go in and start, tinkering with that and getting it fine-tuned. And then also when to regenerate. Obviously, this is how you operate and how often you want to see your toolpath generated. But if you don't have to, you can generate, after you make changes. But on the other hand, if you're making a lot of changes, you may want to generate between changes. So at least you'll know, well, this change that I made, is causing an issue or not causing an issue. And then another thing that can affect toolpath generation is the type of tool you're using. Obviously, you're not going to base your machining tool based on your simulation. But if your simulation taking a longer time, then look at the tool type that you're using. Flat end mills are faster, ball mills are slower, tapered mills are even slower, and that just basically because of the way the tool is shaped and how the algorithms work generating the tool paths. Okay, so let's take a look at some parameters that will affect your toolpath generation. This dialog here on the right, the parameters that you see in here are the default parameters. So if you just bought the program, you installed it, and you opened up a horizontal roughing operation, you'll see these default parameters. Now, the two big ones that will contribute to toolpath generation time is your toolpath tolerance here at the top and your toolpath step over. Now, again, we're not recommending that you set these only to get a good simulation. It's just to reverse your thought pattern. So when you get into a simulation or a generation that you think is taking a long time, go back and look in at these two areas. These are the reasons why that it's taking as long as it's taking. The tolerance, just an example, you could reduce your tolerance by 50% and jack up your toolpath generation time by 25%. And these were tests that we performed just this week prior to the webinar. Again, toolpath step over. If you reduce your step over by 75%, you can increase your generation time by 40%. So it's just a way of looking at it. And then another area that can contribute to that is your cut pattern. The offset cut pattern is the fastest pattern. That and the linear, those are basically the same amount of time, depending also on your geometry, obviously. But if you went to an offset spiral, expect your generation time to double. If you go to a spiral, expect it to double with even a little bit more than that. A radial, it jacks it up a lot, only because on a radial, it works its way back and forth. When it gets to the end, it'll retract and go back and do it again. There's a lot of retracts, so there's a lot of time involved in a radial toolpath. But there's times when that's what you want to use, so just be aware of the generation time. And it's even faster than a high-speed toolpath, which has a lot of tangential motions in that path. So that's just an idea. It gives you an idea of what happens when you change these parameters, how it affects your toolpath generation time. And then also your CAM preferences, you want to take a look at those. The biggie here is if you have a multi-core processor, and most new computers now are multi-core. This particular computer has 4 cores, 4 coprocessors. You want to turn this option on for always generate toolpaths in multiple threads. I'll show you that in a minute, but that can decrease your generation time at least by 50%, probably more than that. And then above that, you have your part sampling resolution. By default, it's set to standard. And what this means is this is how many points across the surface it's going to sample in order to generate this toolpath. And as you know,
I got to interrupt. Sorry, Don.
okay.
This part sampling resolution, it doesn't apply to all toolpath methods. It's only for 3-axis. I think it's only used in horizontal roughing and finishing and some of those types of methods. So so if you're using a lot of those type of operations, these can have a significant effect on the setting can have a significant effect on your performance.
Mm-hmm.
But our general recommendation would be to keep it as standard. But if you have a very small part, let's say you're machining something less than an inch or so in size, then we would want to increase that to fine or medium or fine to get a better quality toolpath. But I guess Don is talking about the effect of the settings on this performance. So,
mm-hmm. And actually, Joe, in the tests that I performed, I didn't see a whole lot of decrease in time in going to the fine. It did some, but it wasn't like so drastic that I need to stay away from fine. But if
Yeah, it's a linear decrease, so it's not that significant. When I say linear, it's not quadratic or exponential. So you would see some decrease if it go to fine, but not too much.
mm-hmm. And then
Yeah,
at the
you're
top
right.
here, you can set your default operation tolerance for all of your operations, and that's set at 1,000 by default. Okay, let's show you a little bit of about the things we just talked about for toolpath generation. We're going to go back over to RhinoCam, and then we're going to load this part model here. Okay, so here's the model that we showed on that graphic slide. And one of the things that we're going to show you is what happens when you tighten up your tolerance. Now, tolerance will affect how many, correct me if I'm wrong, Joe, but tolerance is going to affect how many sample points, how many motion points you're going to have in your 3-axis toolpath. So if you're running a path across a curved model like this, and you have a really tight tolerance, it's going to take longer to generate. So
Yeah, that is the side effect of tightening the tolerance, because internally what happens is the geometry is, we internally, excuse me, in 3-axis toolpaths, internally nerve surfaces are converted linearized in some places. So when we do the linearization, the tolerance affects the linearization. And if the tighter the tolerance, the more data the system is using, that is the CAM system is using in its computation. So it results, like what Don is saying, is it does result in more toolpath points, but that's just a side effect. But the main effect is it's increasing the data being input into the CAM system.
okay. And what I was going to do here is I was just going to go into the parallel finishing cut parameters. We have it set at 1/2 thousandths. I'm not going to tax it a whole lot, but I'm just going to set it at 0.1, which you probably would never use, but this is going to just show a baseline. And let's just generate that. Again, I apologize. I had a stopwatch I was going to use to do these, but that was so fast. Maybe, 4 seconds? It generated that. Then go in, let's try 0.01. I'm not going to run it at 0.0005 only because I've got a lot of things running on the computer right now with the webinar and everything. So we're going to keep it within reason here. That was 10 times. So even that was pretty fast. You can tighten up even more. If you tighten up to 1/2 thousandths, it's probably going to take you 30 seconds to generate that, maybe a little bit more. So the next thing I wanted to show you was that, well, there's one thing here that I had that we didn't mention, and Joe, you had mentioned this to me just this previous week when we was going over this. The way the toolpaths are generated, based obviously on the geometry, but it's based on what geometry is visible on the screen. So if you have a lot, and obviously in support, we look at a lot of people's screens and we see how they work. And a lot of people have a lot of geometry on the screen that's not needed. So if you've got, keep your geometry separate, you probably got it already separated on layers. Turn those layers off that are not affecting what you're working on. That will increase your toolpath generation time. Just keep it clean, keep it simple, and keep it fast. So the next thing, I've got another part I want to load to show you one other thing here. And
One other note I want to make on the tolerance, again, what tolerance to use, we run into that a lot with customers. That question, what tolerance to use, is really very similar to the question about what type of meshes should I be using. So again, using the right tolerance is very application based, and really you have to fine tune it, do a lot of experimentation yourself on the type of parts that you're machining, the size of parts you're machining, the material, as well as the machine tool that you're using. So there are a lot of factors that would determine the sweet spot, if you
Yep.
will, for
And
the operation tolerance.
and also, we have a blog article on that toolpath accuracy. There's a host of other things you want to look at if you want to get that accuracy out to your machine tool. I recommend that you go and read that article on our blog. It goes through what you need to check, a checklist of things you need to do to get the accuracy that you're seeing on your computer out to your controller. So what I wanted to show you here was toolpath generation. We're still on toolpath generation. Let's go into the preferences. Let's go to machining. Now, you saw this. I mentioned if you have a new computer, it's pretty much assured that it's multi-core. So that means that you have more than one central processing unit in the motherboard. And you can take advantage of that by making sure this checkbox is checked. It says always generate toolpaths in multiple threads. So I'm just going to give you an idea of how quick you can generate with that turned on. We're just going to right click on the setup. I probably have 30 operations and pick generate, and it's running them all in all 4 cores, and it gets through all of them in probably 4 or 5 seconds. Now, if I turn that off and run it, I'm not going to do it, but it will probably take a minute because it'll generate one and it'll generate the next. It's just one operation generated at a time. So you want to have this turned on all the time. Okay, so let's go back to our presentation and let's take a look at simulation. So this is an area where a lot of users are concerned about. We get a lot of calls about, hey, it's taken forever to simulate. What's wrong? Okay. Well, it's not that something is wrong. It's just that you probably don't have your settings set in order to get the best performance that you can get out of it. So let's just start at the top. What are the performance indicators for simulation? Obviously, it's your geometry, the stock model, the size of your stock, your control geometry, your containment area. You know how large of an area are you cutting or are you simulating? You can think of it simply as more motions, more time. Okay, the more times that tool moves from point A to point B, the more time it takes to simulate. But there's a way around that, and we're going to show you that trick in a minute. Simulation preferences obviously also play a major role in how fast you can get through a simulation. Now, some tips related to increasing your simulation time. We have different simulation models. One's called a voxel model, one's called a polygonal model. Now, just to mention, if you're using the express configuration, you only have the voxel model, so you don't have the higher accuracy polygonal model simulation. I just wanted to mention that. And then also we're going to go over what does it mean to simulate by moves versus by distance, because they're in the default settings, one is faster than the other. And then simulate until, this is a little trick that I mentioned about. I'm going to show you how to bypass everything and just cut right to the chase and get your simulation model displayed. When and how to simulate, that's basically, the way you work. There are things you need to be cognizant of, though, when you go to simulate a model that has a lot of tool paths. And then again, in your simulation, the more accurate the simulation, obviously the more time it's going to take. Okay, so let's take a look at the default simulation preferences. So on the left, you see the CAM preferences dialog. We're looking at the simulation tab. Now, these top 2 areas, simulation model in simulation mode. The mode correlates to, if you look at your simulate tab down below here, you have a checkbox for simulate by moves. Okay, so this correlates to the simulation mode. But let's talk about the simulation model. For many 2-axis and many 3-axis, and Joe, you can jump in and tell me which ones that don't apply, but many you can run in a voxel model simulation, and you can drop that simulation time by over 300% in our tests just by using the voxel model. Now, it's going to be less accurate of a representation, but if you understand your model and how it's going to work, you can use that to get a quick view of what the toolpath looks like.
Let me jump in here, Don.
Okay.
So the voxel model, there was a question by one of our attendees who's saying, what is a voxel model? It's a good question. Everybody's heard of pixel, right? I mean, pixels are basically picture cells on your TV or on your monitor, computer monitor. Very similar to that, internally what we do in the CAM system is these pixels, instead of just pixels, we actually create volume cells. So these are, dots on the screen, but they also have a Z depth associated with it. So we call them voxels, so similar to pixels. And so you can think of it as, a voxel model is nothing but a volume model that we create of a part file or a stock file. And that's what we use for simulation. And the voxel model has restrictions because it's dependent on the orientation of the tool. And for all 3 axes and 2.5 axes, as Don mentioned, you can use the voxel model. But the minute you use different setups, as you might use in a 4-axis setting or a 5-axis index machining, then you cannot use voxel model because you're coming at the part and machining it from different orientations. And the voxel is inherently limited to the Z-axis of your toolpath. So as long as you're using just one Z-axis setup, the tool axis is pointing only in one direction, which most of the 3-axis toolpaths are, then you can use the voxel model. So, and it's much, much faster and uses a very much smaller footprint than the polygonal model. I hope that helps.
Okay, let's take a look at, a lot of users get confused about the simulation mode, okay? Now, you got 2 choices here, simulate by moves and simulate by distance. What this means is how many times that model gets refreshed on your screen, okay? So in the background, in the algorithm, it's calculating all the toolpaths, it's going through all the model, but you can control how many times it shows you the model during the time it takes to generate the simulation model. So if you don't care to only see the toolpath 5 times versus 35 times, then you're gonna really decrease the amount of time it takes you to get through that simulation. And you can control that by, if you simulate by moves, you can adjust this value right here, which maximum display interval. So the default display interval by moves is 100. So every 100 moves, the simulation on your screen is going to refresh. Okay, and you can increase this to say, I want to refresh every 1,000 moves, and that can really speed up the amount of time it takes to get through a complicated model. So you may, you may see a refresh, every, I don't know, I'm just going to guess, every 2 minutes, say, okay, versus 1 every 30 seconds, okay? And again, that's by moves. So if you pick simulate by moves, that's the fastest. And if you look down here on the simulate tab, there's a checkbox for simulate by moves. Using the default parameters, check the simulate by moves, that will be faster, okay? And then you also have a slider here, and that relates to this slider down here on the dialog. That just moves up, how many times, again, your display interval, how many times the model is being displayed on the screen. So you think of it on the slider, move to the left, it's slower. Move to the right, it's faster. And then also here, you increase the maximum display interval, that's going to be faster. You decrease it, that's going to be slower. And then the simulation accuracy. If you're using the voxel model, you can enter in the volume size, as Joe mentioned, which will affect the simulation time. But you can
Well,
also go ahead.
sorry, Don. Just wanted to correct that. It's not the volume size. It's really the spacing between each of the pixels is what you're affecting there.
Oh, okay.
So
Okay.
the more the denser or the tighter the spacing, the more accurate your representation. And then one other note I wanted to add is these settings that you're changing are not going to affect your toolpath at all. The toolpath is already done. We're just using this for simulation. So it'll affect the quality of the simulation display on your screen, but your toolpath quality is going to stay exactly the same. So.
Okay. Again, there's a slider for accuracy, standard accuracy, medium, and fine. Just be cognizant of the fact that if you jack it up to the right, you're going to slow down your simulation time. It could be as much as 200, 300%, for 2 or 3 times longer by using a finer simulation. So if you don't need to, there's no need to. So then also I mentioned the trick. If you want to bypass all this gobbledygook and cut to the chase, just right click on your toolpath operation and pick simulate until. That just bypasses everything. It doesn't show you anything until the end. So it's just going to calculate. It's going to calculate, and then it's going to show you the final simulation model. So if you're worried about time, go ahead and use the simulate until. So also being aware of the fact, if you're simulating until and your operation is 12 operations down and you simulate until, it's going to calculate all the operations prior to that. It's not going to show them. It's just going to calculate them, and it's going to get to the one that you simulate until, and that's the one that's going to show on the screen. So in most cases, if you just want to see the simulation, just pick simulate until, and it'll bypass all this other stuff that you if you don't want to worry about it. So there are a couple of things that was interesting though in our tests. In our tests with the shoot, Joe, that word just kept out of my mind. The shoot, let's go over here. That is the material texture. So what I'm getting at here, if you assign a material texture and you have it displayed, it reduces your simulation time by 25%. Now, why was that? I haven't figured that one out yet, but that's the result that we got in our test. So,
Well, it depends on your graphics system too. So
yeah,
graphics card. So some graphics card can do it in the hardware, the texture display.
yeah.
Texture display typically would take longer because you're adding additional, computations for
So
displaying the
basically what we're
model.
saying then, if you have a so-so graphics card, that might take longer.
Right.
If
Yeah.
you have a
So
good, a good one.
the more you tax your graphics by adding textures and different light sources and things like that, it's going to slow things down. So.
Okay. Well, I guess on this, because we had a good graphics card in this machine, it actually went faster. So that's just something to think about. So also over here, if you if you're in a pro or premium configuration, if you gonna simulate your machine tool, that's where you have your machine tool on the screen, and you're actually seeing the axes of the machine tool simulate along with the part. Just be aware that's going to tax your system another 15%, so it's going to slow it down. Okay, so let's. We got about 5 minutes. I'm going to try to show you a few simulation things before we end up here, and I wanted to go into this part here. I want to show you the voxel simulation. So let's go over to simulate. Let's go to the preferences, pick the voxel model, and we're going to pick OK. And we're going to run through the simulation real quick. So this is the how fast it went through on the roughing operation. It took like 2-3 seconds. Now, Joe, you mentioned that there is some artifacts in this in the Z-axis. If you zoom in and you see these, this is not in your toolpath. Those vertical artifacts.
That is the voxels. You're basically looking at the voxels displayed there.
Mm-hmm. So, you know, don't worry, it's not in your actual toolpath. So let's do the parallel finishing on the voxel. So it's going to whip through that pretty fast. So that's like, I don't know, 2 seconds, 3 seconds. Now, if we did that with the polygonal display, click OK. And we'll check our preferences. Okay, I have it set to 1000, so it's going to be pretty fast. Let's see how much faster or how much slower it is than the voxel. We'll run the horizontal roughing. So it wasn't a whole lot slower. Now, that's one thing I was mentioning. By default, this is only 100 for simulate by moves. So that by default, you're going to see 100. So if you just did this by default and you simulate it, it's a little bit slower. Okay. Just, you know, that's something to be aware of. If you're going in a simulation, it's taking forever. Don't worry. Just jack this number up. You know, I jack it up to 1,000. Let it only, you know, update the display every 1,000 moves, and then simulate it again. You'll see that it goes faster. And let's do the simulation, the parallel finishing. You know, there's a lot of tool paths on that parallel finishing path. I showed you them a moment ago. Really dense step over, but it's cutting through it pretty fast. So let's just pick pause and go to end. Doing that.
Looks like we lost Don there. Don.
Can you hear me?
Yeah, you're
Okay.
back now.
Okay, sorry about that. Looks like I locked up the part because I did oh, there it is. It freed up on me. So, you know, it gives you an idea. You know, I turned down the, used the polygonal simulation, which was slower. Turned down the number of displayables was slower, so it just slowed down everything. So on the simulation performance, let's see if there's anything else I want to show you. Joe, we got any questions? We're about right at an hour. I think I'll stop it here. Joe, can you hear me? Looks like
I think no. I'm sorry, I was muted. I think we're good. We're almost out of time, so there are a couple of questions we can answer by email. And thank you everybody for joining us again. We will be continuing on your input on webinars, and if you have any other questions on or suggestions on what webinar you would like to see, please send it to support@mecsoft.com.
okay.
Thanks everybody for joining.
Appreciate it. Y'all take care.